Okay guys, so real quick I want to talk about this M&M lab, which we ended up doing with beans, worked out okay, but there's a couple of things that I do want to talk about. So first off, for bullet point number 2, you guys are going to have to make a data table, okay? And they list all of the things that you need to calculate and put into the data table, but I think there is a little typo. So where it says relative abundance, and I'm going to change that here as well, I think they really mean relative percentage, okay? Which is different than relative abundance, okay? So we talked about relative abundance data, and relative abundance is whenever you have all of your data on the mass spec graph and the highest percentage is assigned the abundance of 100, and then all of the other values are assigned relative to the number 100. That's different than this relative percent. So let's talk about exactly what you need to have in your data table, okay? So first off, what I would do is I would put the colors along the side, or you could do it on top and then have the data going down, but the first column needs to be the total mass. So, you know, the mass of all the black beans, the mass of all the white beans, the mass of all the brown beans, okay? The second column needs to be the number of beans of each color. So how many black beans, how many white beans, how many brown beans. Okay, that's the second column. In the third column, you guys have to calculate the average mass of a black bean, a white bean, and a brown bean. So the way that you do this, and I put it down here, okay, see, right there. You're going to take that total mass from the first column, so the mass of all the black beans, and divide it by the number of black beans that you had. Okay, you do that for each color. Take the total mass of all the beans of that color and divide it by how many beans of that color you actually had. Okay, so that's how you do the third column. In the fourth column, you need to calculate the percentage of each color. So the first thing you need to do is add together the number of all the black beans, white beans, and brown beans. So add up the second column, okay? Once you have the total number of beans, you calculate a percentage the way we always do. You'll take the number of black beans and divide it by the total of all the beans and multiply by 100. Same thing for white. You'll take the number of white beans, divide it by the total of all the beans, and multiply by 100. Okay, so you should get percentages in this column that add up to 100%. Okay? The next column is relative percent. So they called it relative abundance, but that's not what it is. What I want you to do here is convert that percentage back to a decimal number. So all you're going to do is take that percentage, divide by 100, and that becomes the number that goes right here. Okay? And then you're going to take that decimal form of the percent, relative percent, okay, the percent in decimal form, and you're going to multiply it by the average mass of the beans. So this third column right here, like the average mass of one black bean, the average mass of one white bean, the average mass of one brown bean, you're going to multiply that average right there times that relative percentage in decimal form right there, and that's going to give you what goes in this column right here, relative mass. Now if you look at that, you are taking the decimal form of the percent and multiplying it by the mass of that isotope. To get the average atomic mass for this element, you then add all three of these relative masses together. Okay, adding that column together, that last column, should give you the average atomic mass, because remember the formula for average atomic mass. It's the decimal percent, aka relative percent, times the mass of that isotope, plus decimal percent times the mass of the next isotope, plus decimal percent times the mass of that isotope. So once you do that and add this column together, that should give you the average mass for this element, okay? So again, one more time, where it says relative abundance here in the second bullet point, change that to percent. And all you're doing is simply taking the percentage that you have of each color and dividing it by 100 to turn it back into a decimal, okay? And I changed that here as well. Question number 1, I didn't have you guys compare data in class, so just go ahead and scratch off question number 1. Question number 2, compare relative abundance and percent abundance. So remember that relative abundance, we did this in our notes, we assigned the highest percentage of value of 100. So make sure that you guys give me a clear differentiation between those two, okay? For question number 3, you're going to compare the value for average mass of each isotope. So again, that last column. So you're looking at that last column to get that. Actually, I'm sorry. That's the relative mass. The average mass of each isotope is that third column, where you just have the mass of a black bean, the mass of a white bean, the mass of a brown bean. Okay, so you're comparing the third column to the last column in question number 3 on this assignment. Okay, and then questions 4 and 5 you guys should be able to do. For question number 5, you are doing 2 graphs. Okay, with one of them you are putting the mass of the isotopes on the x-axis, and then you are putting their percent abundances along the y-axis. For the other, you're doing relative abundance. So again, that highest percentage is assigned a value of 100, and then the other values are assigned relative to that. Okay, use your notes to help you do those calculations. This is due tomorrow.